So that was our introduction. Those are relations. Now, a specific kind of relation is called a function. So here's the definition of a function. For something to be a function, each value of x must have only one value of 1. And we use the word function in English language when we want to say something works or when something doesn't work, right? Like if you go to your calculator and you go 2 plus 3 and you push enter, it should always give you just one value. It should tell you 5. It would get a little frustrating if your calculator said, just started changing it up, right? Like 2 plus 3, 7 today.
You have 7.
Like what? That would get a little bit confusing. So, a function is always a relation, but a relation is not always a function. For example, if we go back to our dogs and height, right? What did we have? We had the Chihuahua be, what, about 20-something centimeters? Could it be possible that a Chihuahua, your Chihuahua is different height than somebody else's Chihuahua? No. So all of a sudden it's like, it's not like you have a Chihuahua and it's always exactly this height. They're like perfect. Every Chihuahua is perfectly the same height. Okay? So that's a relationship, but it's not a function because it's not like, oh, Chihuahua is perfect that height.
Yeah, I saw a corgi 70 centimeters. I'm serious. Believe me if you want.
So if
It was like big corgi.
Yeah, it was really like a corgi, other big dog.
I'm going to give you 3 ordered pairs. No, you don't write this down.
Okay.
Damn, bro. There's group 1. I'm going to do group 2 in green.
Do we write it?
No, I don't want you to write this down. One of these is a function, and one of these is not a function, or they're both functions, or they're both not functions. So you have to decide.
What are we deciding?
You have to decide if the blue set, does that make a function or not? Does the green one make a function or not? The definition of a function is each value of x must have only one value of y. Can you apply that definition and say, is this a function or not?
Yes, it is a function, but green is not.
Oh, so some people say this one's yes, some people say this one's no, some people say this one's no.
No, that's not a function. Green is not, blue is.
So, green is not, because we have a value of x that has a different value of y. This is like your calculator saying
3 plus 4 is 10 now.
x plus 4 is equal to what? If you plug in 2, you get 6. If you plug in 2, you get 7. This doesn't make sense. This one is not a function. This one is a function. You can have the y value repeat, but each x value has to have only one y value. What is the x value for, if the x value is 3, its y value is 7. It has one y value. X value 2, its y value is 5. So I have students get confused with this because they see the repeat, right? Here the x is repeating and you have different y's. Here the y is repeating and you have different x's. The definition just says that each x value can have only one y value. So this makes this a function and this not a function. What about this one? Function or not a function?
Not a function.
Not a function, what is 2 equal 3 5?
Not a function.
Not a function.
Yeah, I'm in.
No. This is not a number.
So fast. You can paraphrase.
Yeah, I dumbed it down. No, that's the game.
You're good.
We're good, we're good.
You're good.
I'm good, man, I'm good.
So, what you're looking for with ordered pairs or table values, does the same x value happen more than once? And if that happens, does it have a different y value? They could list this one and have 2, 3 listed twice. Then it would still be a function. It's just repetitive that they've done the same thing twice.
It would still be a function.
It would still be function if the second one was also 2, 3.
You're ever gonna put that in the test?
Could be, right? As long as each x value has only one y value, that makes it a function. Because it's sort of like, oh, you have the button on your calculator that squares something. If I hit 3 squared, I'm going to get 9. If I do it again, I'm going to get 9 again. It's still functioning. If I did it again and did 3 squared and got 27, I'd be like, what happened? Something went wrong. Function or not?
Yes. Function.
All right, what do you think?
No, not a function.
Never.
Not functional.
Which point is the problem?
It's -3 and
Not a function, which ones? Because we have this. The -3 x value has 2 different y values. Not a function. Good. Which number is the problem?
3 equals 6 and how many equals 4?
3 goes to 6 and the 3 goes to 4. That makes it not a function. Good, are we ready? We call all the x values in a function or a relation the domain, and we call all the y values the range. And so you're going to need to remember that domain goes with the x values, and range goes with the y values. Okay?
Range or range?
Range. The domain and the range. I had one student one year, he said, well, you know how I remember it? I just call it domain and rangey. And he put a y on the end of the word range. And then he always remembered that range was with y. And then obviously domain had to be with x. Rangey.
Oh, range X.
No.
Don't do that.
Don't, you just messed up everything. Oh my god, I already forgot.
I mean, it's much easier to say rangy than it is to say
Range X.
domains.
Domain X?
Domains.
Domains.
That's kind of nice.
But it's kind of got a nice ring.
Domains, rangy.
Like a lynx, domains.
Domains. Domains. You know, like say with the accent.
So, this is the thing, when you learn something new, sometimes you create something like that to help you remember it. So, and I have to admit, sometimes you do these things, and you remember things for way, way, way too long. I can still remember all of the Native American tribes of the Eastern Woodlands from my grade 10 history class.
I remember you told us.
Because I made up a song. Did I tell you this already?
No, we haven't.
Yeah.
I should sing it again?
Please,
Okay.
You get a guitar from
No, I'm not gonna get it. Micmac, Malasite, Algonquin, Creole, Ojibwe, Montagnais, Beoda. The one didn't fit into the song, so it had to be at the end, but it's really sad because that's actually a tribe that was extinct. And I remember all of this because I made up that silly song. But when you do things like rangy and domains and silly things like that, and they can help you remember the definitions early, that can help you later on. Okay, so are we going to remember that range goes with the y values? Domain goes with the x values. And you will see and hear the words domain and range a lot in math classes from now until you finish AP Calculus in grade 12.
You think I did my calculus?
So, when we have single points, like this one, we write the domain with a squiggle bracket. And what are the x values?
3, 1, 0, negative
3, 1, 0, and negative 2. What's the range?
2. 2, 4, 4, 2.
And you don't have to write them more than once. You could write just 2 ones and 4 ones.
You have to do squiggle brackets or like for range and
You would write for the range of the domain when they're a set of single points. Okay? Is this one a function?
Hold on.
Yeah.
Yes, this is a function.
Yeah. It could be y function. I like it so. My brain is functioning.
Your brain is functioning. I like it. Okay, domain.
4 and 5.
4 and 5.
No.
7, 8, 9.
Is this a function?
No.
No, because 5 goes in.
The number 5 has 2 values that it goes to. question says, is this a function or not?
No,
No.
not a function, not even a bit.
Not even close, like there's lots of things bad with this one, right? The 1 and the 4 are bad. But we can still say the domain. What would the domain be?
1, 9, or 1, 4, 9.
1, 4, 9.
And negative 3, negative 2, negative 1, 1, 2.
So now we can make a connection in the next example to a unit we've already done. Do you remember doing the prime factorization? Okay? Prime factorization where you would say that 4 is equal to 2 times 2. And 6 is equal to 2 times 3. And 8 is equal to 2 times 2 times 2.
Oh.
Right? That would be the prime factorization of 8.
Oh, I see, okay.
Okay? So here we have a relation that associates a number with a prime factor. Okay? We need to say if this is a function or not.
No.
Not a function. Why?
Because 6 is not equal to and 3.
Because 6 has 2 prime factors, 2 and 3. And so this doesn't make it a function because 6 could go with 2 or 6 could go with 3. Right? And we can point to the problem right there. But we can still do the domain of this function so far. And we can still do the range. 4, 6, 8, and 9 is in the domain. And the range has
2, 3, and 4, yes.
just 2 and 3. Function or not?
Yes.
Well, yeah, it does.
Yes.
In reality, though, is it really a function? Like if we actually think about months, is it ever possible that a month has a different amount of days?
Never.
Yeah,
yeah.
Oh, wait, what month?
February sometimes has 29, right?
It's not a function?
Well, according to the data that was given, this with the data that was given in this question, we would say function. But in reality, if you think, oh, sometimes February has 29 days, that would make it a relation, but not a function.
How many months of the year have 28 days?
All of them.
Yeah, that was a joke. Someone's gonna say what?
Hey, look, this is in French. Love it. All right. You okay if we shorten it like that?
No.
And then the range. We're going to do 2 more. We're going to do example 6 and 7 and then stop. 2 more. Here we go. The amount that you get paid, we talked about this earlier, depends on how many hours worked. We always say that independent is listed first, Dependent is second. We always think of our first values as our x values and our second values as our y values if you were going to graph this.
They're not even making minimum wage.
Yeah, they're not doing very well here.
Yeah.
They're making $12. Oh, what is minimum wage? That's isn't it
$13.50.
$13.50 now?
They're not even making minimum wage.
We always write independent first, dependent second.
Yeah.
And you always have your domain first, range second. So here's our last example that we're going to do. Here is a relation. Can you see that it's also a function? There's no x value listed more than one. So if you always have different x values, then you for sure will have a function. So we can say to this one, yes.
You say yes.
Oh. But why is this why
Oh, why is it?
Yes.
That's a good point. Why is it a function?
No, yes. Yeah, I think you would fix it. What does that mean?
No x value is listed.
I'm gonna write that on the test and then that's
Independent ones is the number of marbles, and the dependent
That's
is the mass of the marbles. Domain and the range. Oh my goodness, too many decimal places.
Yeah, I'm not writing those ranges.